Hi guys, let's talk a little bit about zero trust connectivity. I think that there's a lot to discuss and a lot to discover. So I'm here with David, and let's just jump right in. What's this all about? Okay.
Yep.
One thing that I think we all need to just hit right off the bat is just because zero trust is a hot topic in security. And just because someone put ZT in marketing doesn't mean that it's actually solving the problems or making proper steps forward to solve what zero trust is set out to solve.
That's right.
Okay, I think that's a very, very important thing. And then the other thing that I think is important that I've come across, I don't know what you see, David, but when you read the white papers of zero trust, okay, it all's very good philosophies. We actually completely agree with all of that, but then you get to the end and then you realize that, this is not really necessarily implementable for a lot of guys.
That's right.
It's not practical. So it's kind of like you read this philosophical thing. You're about to chase the unicorn milk, but you will never find it, right? Because it says that most people will somehow end up in some sort of hybrid. So some holes will be patched.
Yeah.
Some things will be, but that's still not good enough, right?
Right.
So where did this whole zero trust notion come from? And I think the first thing to understand is that it really is a reaction to failure. Okay? Traditional security systems and traditional security philosophy was failed. And really what it came down to is to say the old castle wall approach is to say we have this wall and everything outside the wall is bad or maybe not trusted. Anything inside the wall, once you're there, you're part of the club, it's all good now, right? Really what it comes down to is to say, because the philosophy was wrong on this castle wall, in how we implemented the castle wall, now we just say, let's not even think about the castle wall at all. Let's now just talk about identity. Verify devices amongst each other, right? What I find interesting is at the moment that you actually verify between these devices, all you're essentially creating is a new complex shape of a castle wall, right? So instead of it being one big thing, now you have lots of bubbles everywhere. Maybe it's remote work, maybe it's different sites that need to be connected together, maybe it's different services and cloud services. So, but really what we are dealing with is a different shape perimeter, flexible perimeter. And so if the whole idea, and you know what, I understand it, because sometimes if you have an unbalanced scale, things were wrong with this whole castle wall approach. You have to overweight it to start getting the scale into movement. But really we need to get to a place of being practical and say that the perimeter is even more important than it was in the past, because now you're dealing with a flexible, complex shape perimeter.
Right.
It's not about the walls. It's about the doors and the locks. And that's really what I think we need to dive into quickly. So David, what are the main things that comes to mind for you as to why the traditional firewall has died? Why the conventional security has failed? What would you say are key things that come up for you?
The first key element on why the traditional role of a firewall couldn't function anymore is because we needed to implement a practical way of doing egress control. But that wasn't practical in a traditional firewall because when you would firewall for egress control, it was very static. It was very set at a point in time, and it was really not maintainable very well.
But the same would be true also for ingress, right?
Well, the same thing would apply to both directions. That's right. It was very static, and so you didn't have a dynamic nature in a traditional firewall. And then what we tried to do that also didn't work very well is implement a proxy technology where the proxy would then be of a more dynamic nature. But then it's so full of problems and compatibility issues. And then we did transparent proxies, which had a problem where it could not protect secure channels anyway. So little by little, we just started letting more and more stuff through that was not inspectable. And that was another core part of the issue, was that as Edward Snowden revealed to the world how much information was inspectable, and that was used with malicious intent or breaching our privacy and our security, then we said, okay, then let's start securing the transit more. So when stuff goes from me to you on the path, it's encrypted to where it's not inspectable. Well, that means that the firewall now cannot inspect it either. And so all of these things together added up to where the traditional firewall was no longer relevant.
And then, of course, so you can't do packet inspection. ESNI is a problem. DOH is a problem. You suddenly can't see what's going on anymore. DNS still has value, right?
Yes.
But there's this inherent problem with leakiness of DNS, right?
Absolutely, because with the internet being both DNS and IP based, and then applying a DNS-based firewall, it simply does not apply to stuff that doesn't use DNS. And so inherently, that's where all peer-to-peer traffic, for example, would just walk right around that DNS firewall and not use it at all. And so it always had limited application.
So we almost need to just think about, those three circles of the changes that have happened on the internet, where first it was, let's just get stuff to work, right? And that actually happens not just on the internet, in pretty much any technology. Just get stuff to work. That's our first circle. And then from there, we say, well, let's get it optimized to work better and be more resilient and so forth.
Right.
But now you get to this third aspect of saying, well, I never thought about security, right? And that's the third circle, and these are kind of in tension with each other.
That's right.
And right now we're in this third phase of saying, we got stuff to work, we got it optimized, but how do we actually secure it? And that's really where I think everyone's finding themselves. So applying that to DNS, what would you say is inherent design flaw in it?
Well, the inherent design flaw comes by form of history, which is very well documented, but where we are today is that we have, if you can visualize, two doors for our devices to reach out to the internet.
Right.
One door is the DNS door, where we go out and say, hey, where's google.com?
Sure.
And then we come back and get the answer, and then we go out the other door, that's the IP door.
Okay.
Right?
Right.
So the IP door, generally speaking, in most environments today is wide open. But in many places where they put in a DNS firewall, they have put in a security officer at the DNS door.
Right.
So when you say, where's google.com, you'll get the answer. But if you say, where is this bad website.com, the security operator says, no, that's not some place that you're going to go, so I'm not going to tell you what the answer is.
Right.
And so therefore, you don't know where to go and you can't go there.
But this is the nice guy. We're not talking about malware. We're talking about a user that needs to be protected, that's willing to actually ask the security guard, ask mom or dad, hey, where do I go for this? And they're at the door.
And DNS firewalls have been around for some time now. So this is not a new concept to the guys that write malware.
Right.
So the guys who write malware, they're like, we know that in places where there's high value assets, we're not going to use DNS because then we're going to leave a digital trail and they're probably not going to let us out. We're going to go without. We're going to use some other kind of a channel to figure out the IP addresses that we need to connect to where our command and control server lives, for example, and we'll do that instead.
Sure.
And that is what we refer to the inherent leakiness of a DNS firewall.
Yeah.
It only goes so far to protect the good guy who's a user. It cannot protect malicious software that just bypasses DNS altogether.
Right. And so then, it's sort of like this whole notion came where, okay, we can't really protect, the perimeter is already breached. So, and then next generation firewalls came in to say, well, let's detect, let's see what's going on. So now we have the security guard standing inside the castle and just looking for anything that's bad, and then raising an alarm when that is. Well, problem is that a lot of them requires endpoint agents, right? And so what about IoT devices where you don't get to put your endpoint agent? Well, what about these guys? Well, that is a problem for sure.
Right.
And then that really brings us to the core issue, is that now you've moved from a proactive to a reactive approach. In actual fact, this whole movement is still reactive to a very, very large extent. This isn't working, let's change that. This isn't working, let's change that. This isn't working, let's change that, right? It's reacting versus taking a true step back and say, well, let's design from first principles. What do we actually need to see happen here? And that is true proactive, because even with next generation firewalls, you're still in a reactive approach, because real-time detection is not fast enough. So Larry Gage taught us that. Yeah. And I mean, the guys that were hit by this, they're black belts, right? So US Treasury, CISA, DHS, U.S. Department of State, the list goes on and on, right? So 6 months before detection, and suddenly there's no protection actually that's happening there. Right. So the reality is that if you've skipped this protect phase, you just want to go to the detect and remediate phase, then you've already gave half the battle to the bad guy already. And so you might have a proactive approach in your security for your company or for your organization, but the tools you use are still reactive. You're still reactive, okay? And that's another thing that I think we need to just identify. Another important thing to think about with this whole reactive versus proactive approach is that with a reactive approach, meaning you're keeping track of what is bad, with the best threat intelligence that you get in the world, right? You can only be protected against some known threats from yesterday, okay? Any undetected or any unknown thing that is there today or tomorrow, there is no protection against it. And so there's this philosophical problem with blocklisting, with the reactive approach, and that is that there's always a victim.
That's right.
And I don't want that victim to be me or people that I am protecting or that I care about, right? And then the next thing is, well, it is maybe known for this threat intelligence source, but maybe not that one, right? And how much time goes by since it actually becomes known until it becomes available, right? And those are key things that needs to be considered. So even if you have a proactive approach for security for your organization, but you're using reactive tools, okay, then you are still reactive.
That's right.
That means that the bad guy is always one step ahead of you.
Right.
All right. That really brings us to zero trust connectivity, right? So what are the core concepts in the philosophy that to you sits right at the bottom?
Well, the one that is absolutely top of mind for anybody who's been in this field for some time is don't give me another product unless it's practically implementable right away.
No unicorn milk for me.
Right. Show me how it's done, and so that I can do it today. Right? Okay. It has to be practical, has to be available right away. That would be the number one.
Okay. And then, of course, assume that you've already been breached, right? Just assume that. And then, but wouldn't it be interesting if your remediation for if you have already been breached is the same that you use for your protection? Wouldn't that be something? All right. And we'll dive into that a little bit more.
One of those components would be the next item, which is having leak-proof egress control. I want to be able to have the peace of mind that I can plug in an Ethernet device or attach something to a Wi-Fi network and know that it cannot do anything unless I've given it permission to do so first. Right. So that has to be leak-proof.
So, and really the concept is say, we stop going to try and keep track of what is bad. We're going to move our focus to keeping track of what is good.
That's right.
I mean, of course, bad and good, you have to keep track of both. But I'm saying the focus of this goes to let's verify what is good, keep track of that, and those are the only connections that are going to be allowed, right? So any new connection, everyone's bad, trust no one, deny all connections by default, all right? Unless it's verified to be good and is requested by actually one of your verified assets, right?
And in order to do that, we have another requirement, which would be that we need to have maximum visibility to each endpoint. We don't care if that device has its own firewall turned on. We need the visibility and have it not hide behind another bridge, not have it hide behind another router. And if it is, for it to be obvious, right? So that this whole shadow IT environment becomes exposed.
Right. So you absolutely need to have inventory of every single device that lives there. And the thing is, this needs to happen automatically.
That's right.
So human error gets, it's out of the equation. This has to be part of, if you're connected, it's known that you are there, right? All devices must be protectable. Like even if there is no way to put an endpoint agent on that device, you must be able to protect it, right? And keep in mind that the supply chain now involves the homes of the employees that are working remotely to your suppliers. So the smart light bulb or the network camera or to whatever the thing is, all of those things now suddenly become part of this crazy mush soup, okay, of what needs to be protected. So So with zero trust connectivity, you must be able to apply protection to an IoT device that cannot take your endpoint software. Okay?
As it is in read-only firmware mode, it needs to be protectable if you're going to maintain a zero trust network.
And not to make it too mysterious, of course you can do that if you protect that connection. That's right. Okay, and
And another important element is that nowadays we live in a world where we have free open source threat intelligence, we have community crowdsourced threat intelligence, we have commercial threat intelligence. Well, we need to be able to combine them all in real time to provide protection, because this one source may know something that another source doesn't know. This applies to the real geopolitical world the same as it does in the cybersecurity world.
I absolutely agree. What is the best threat intelligence in the world? It's not this guy or that guy, which is number 1, number 2, and maybe tomorrow this is number 1 and number 2 and number 3. It is combining all of them together, and whatever graph or AI data, but whatever you're implementing, you want to be able to combine that threat intelligence. So that's a core tenet of zero trust connectivity. But then also being able to apply it proactively, meaning that it's not the same old, let's know that it's there, then we block it, or let's detect that it's there, then we block it. No, you just block everything and you use the threat intelligence to focus on what is actually good, verified, and what can be trusted.
That's right.
Right? It's the other way around.
Flipping the table on the bad guy is how I like to think about it. And flipping the table on that too is making sure that that protection is done custodially on a distributed basis.
Right.
What we mean by that is these boxes need to offer protection in as many places as possible without relying on a central cloud service to proxy things through.
Yeah.
That's distributed custodial protection that we think is important.
Right. And, let's talk about, flexible perimeters. The reality is maybe you want it to live on the cloud edge. Maybe it needs to go with this device. Maybe the perimeter sits on this device itself. Maybe you want to put this in an access point network, in a cellular network. So it needs to have flexible perimeter.
Right.
That can, and they are not static.
Right.
Because if my machine, this endpoint, is allowed to access my banking while during the day when it's time, there's really no reason for it to be able to do that at 3 a.m. when I'm not doing that, right? So it needs to open and it needs to collapse when not verified and not good. And this, so it's not just a static environment that it's okay now, but tonight at 3 a.m. it's okay as well. No.
Right.
Okay.
And then I would add one more, which is circumvention protection.
Yeah.
This is in multiple contexts, not just in terms of having a content filter that's actually enforceable, but also to prevent the bad guys from writing malware that walks around a traditional egress control firewall. Right? So circumvention protection is absolutely essential. It ties well in with the egress control component, but there has to be a purposeful thought into making sure that you're thinking like the red teamer or like the bad guy, and then building in protection against that.
Right, and another one is just don't break encryption along the way.
Right.
It has value, it has security value, it has privacy value. As to try to get into the middle and break that for the sake of inspection, we feel that's not good practice.
No, because at that point, I'm pretty much surrendering my credentials to my banking, my business banking, personal, to whoever houses that infrastructure.
So not zero trust. It's kind of like well, you're shifting that risk. You're just shifting it somewhere where you don't actually have control.
In fact, it should be called focus trust if someone proxies traffic for inspection.
So when we're talking about zero trust in this context, it really comes down to what ADAM 1 became when 6 years ago there was a change of philosophy for you and the team, right, David?
That's correct. It was very obvious to us at that time that all of the traditional ways of trying to identify and block threats was just a runaway cat and mouse game that we could never win.
Right.
We had to take a step back and say, how do we do this properly?
Right. And going to that first principles, and which we'll jump into a second, okay? In my mind, there's really, expressed in Adam 1, 3 main technologies that was birthed from that. And the first is this dynamic allowlisting.
Right.
So either the AI-driven dynamic allowlisting, which is AI and graph first, means it's a default deny all. As an asset requests it, checks to see that it's safe, checks against the graph, and builds this dynamic list as the asset actually needs it to check that. And then or the reflex expression of that, which is more of a category-based threat intelligence first approach to that. Also default deny all, checking at the time of request, opening that dynamic allow list, and then collapsing it immediately after. So that would be the first one. And then the next one would be don't talk to strangers, right?
That's right. In our world, the term strangers is an IP address that was not first resolved by an allowed DNS query.
Right.
So it takes care of that door that before had no protection. You have this DNS firewall in place, but then the IP door made it very leaky. And this is what effectively makes it leak-proof. Now you have a DNS firewall that works.
Not just for the ones that are nice.
That's right.
Absolutely. And then I think the other element that's important to mention is DNSharmony. And that is the ability to aggregate threat intelligence. Whatever threat intelligence source you actually want to aggregate, you can actually do that and aggregate that in real time.
Right. Because gone are the days when you're going to rely on a single vendor for a product. We know this at the global geopolitical scale.
Sure.
And this also applies to threat intelligence. DNS-based threat intelligence, there's so much of this stuff that's good, but we want to bring it all together and aggregate it in real time.
Right, right. So how is this actually implemented? I think we should just give a quick rundown of how it actually is implemented as Adam 1.
Right. Well, at the core, we have a highly optimized DNS caching resolver that is on each network segment.
Okay.
This is really important because it achieves that distributed custodial protection. It's super efficient, multi-platform, so that it can scale across a variety of hardware and ecosystems.
Right, and that's in this brain muscle configuration, that the muscle lives at the edge of whatever perimeter, whether that is inside the operating system of a device, or if it's deployed on the network edge, or it could be a node in the cloud, or it could be forced onto assets with an always-on tunnel, or an access point network through cellular, or anything like that, right? But you have that muscle, and then which is distributed. It's on each of these edges, and then you have your central brain.
That's right.
Okay, and the net result of that?
The net result of that is that you can actually have an environment that allows for that decentralized custodial protection to happen at high performance, at high scalability, without reliance on your particular cloud to funnel everything through.
And now suddenly you don't actually need any endpoint software. So it is applicable to any IoT device or PLC or whatever. If it connects somewhere, it can actually protect it because it's not reliant on that operating system necessarily of the device.
Right, and there's also one other very important element here, which is that the muscle, because it's a gateway, is a highly trusted interface to endpoints. And so therefore we can get really, really good information, even if the endpoint is firewalled, like what the device name is, what the MAC address is, where it's trying to go to, right? And be able to identify the device beyond the typical network scouring devices that look to scan the entire network to see what's around. Most devices now that are modern are already firewalled, especially Windows, Mac, the new iOS, the new Android. So a scouring device can see very little, but the gateway can. And so that automatic inventorying is a really important component.
Yeah. And of course, all of these elements of this tech, I think it's important just to say that this can actually be, it's licensable. So if someone just wants to use the don't talk to strangers portion, or they just want to use the ZeroTrust connectivity with the ZTc adaptive allowlist, these things are licensable. They don't have to displace what you currently have. It can augment what you currently have. And that is another thing that I think is very, very important to just mention. But let's get to the most important part, okay? We spoke a lot about technology and philosophy of technology, but the most important part for me is how does this actually affect humans, okay? Right. If the technology doesn't make someone's life better, if it doesn't make them more secure, what's the purpose, right?
Exactly.
So what are the consequences of effectively implementing zero trust connectivity? And I'll just answer what we have found with applying this through ADAM1. So first of all, right off the bat, there's this idea of a BrightWeb, okay, where every organization have their own version of the internet. You get to press reset on the internet for your organization, and you build dynamically where you can go. You're essentially creating zero trust of the internet, okay, right, without them authenticating between you and being in the same zero trust club as you, that being behind the same bottleneck proxy or anything like that, right? You get to build your own version of the internet. That means any new threat that you don't want to be part of your version of the internet is simply not part of it as you build it. If you properly build this, if all of the processes are running right, it is a new version of the internet unique to every node. Right. Okay, and that is huge.
Absolutely. Another really important consequence is that your attack surface is being reduced by a factor of 7,000 to 1.
At least.
At least that.
Right.
This comes from a real life application of organizations of 50,000 more employees. So it's a very large sample size that it only need about 15,000 domains out of the billion known that are out there.
Right.
And that's how the 7,000 to 1 aspect ratio.
Yeah, so let's say that all domains out of those known domains that are there are all good, okay? So just surface area 7,000 to 1 reduction. But if you think about it, that 83% of new domains we know are for malicious intent, or whatever that number is today, then that number of actual protection of your attack surface is just so much, it's exponentially more, right? And then C2 attacks just go silent, like radio silence to the C2 attackers. The bad robot's already in your network.
This is really important to stress that the radio silence to the C2 attackers, even the ones that are not yet known.
Absolutely.
Because command and control operators in their attack chain at some point always use a IP address without a DNS name.
Okay.
And that's why it's very difficult for those in the traditional sense to be not only detected but then protected from. But with the consequence of zero trust is that those are then actually blocked.
And I think that Pegasus, forced entry,
yes,
SolariGate, these are very, very good examples that properly configured ADAM1 nodes and clients that were behind these nodes were immune to these attacks before we even know. Before we knew that these vulnerabilities existed, just simply because you are properly managing the connections.
That's right.
Yep. And that, I think, is, I mean, we really stop the discussion right there. We can have all of this philosophical discussions, whatnot. This is practical. This is working.
That's right.
And so this is something that we believe needs to be looked at seriously by any organization that wants to be protected.
And that same mechanism also prevents data exfiltration.
Of course.
And in many cases, threats are only identified after a leakage has occurred.
Right.
And what you really want is...
So now your IP is already out there.
Right.
Your data is already out there. So never mind, you being crypto locked, but your data is out there being auctioned again and again and again for the best paying customers. And there's no way that you're going to get that back. Right? So, and then next thing is the human factor. And to me, this is really, really important. Phishing vectors become almost useless in this environment.
That's right.
Because whatever, and by the way, if we think of this on the reactive approach, the old way, this is why phishing is still a thing. Because with IPv6, there's enough addresses to attack every person on the planet, apparently 47 octillion times. That's more zeros that I can write or count without my hand getting a cramp, okay? So you can actually spearfish every person on the planet 47 octillion times without using a single IP address twice. So let that go onto the threat intelligence. Who cares? They just use a new one,
That's
right?
Yeah.
So with phishing, that domain or that IP, whatever that is, that connection that is being attempted there, just simply won't work.
Right.
It's not part of your ZeroTrust BrightWeb, right?
That's right. Yeah, and at the same time, another consequence is that your shadow IT gets exposed, and that's what makes it easy to clean up.
Sure.
Right? It's half the time, and the reason it's called shadows because we don't see it.
Right.
But the moment you apply Zero Trust connectivity, you see all of it.
That's
Nothing
right.
can hide.
That's right. Especially if you say, no connections until verified and good.
Right.
Suddenly Dropbox shows up, and Google Drive shows up, and whatever services that are maybe they were not sanctioned. They were in the shadows, but suddenly they are. They're all exposed, and I think that is actually going to make a lot of people's lives a lot easier,
right?
Especially with remote work and having satellite offices and so forth, right?
I'll give you one example right now. A typical IT manager, ask them how many IP devices do you have on your network?
Right.
They'll say 30.
Right.
It's always 3 times. The moment you put in Zero Trust connectivity, you see it's 90, not 30.
Right.
It's crazy.
Right. Yeah. Another big value, I think, is circumvention protection.
Yes.
And I'm not just talking here about willful employees or members of your organization that, or any assets that are choosing to willfully bypass for whatever reason they might have. There's also the malicious actor.
That's right.
Okay. What's the purpose of putting a door or a wall in place if you can just run around it? And that's really where this whole Zero Trust thing came from, is that whatever was done in the past, you could just simply jump over it.
That's right.
Okay. And then, of course, privacy, because you do not need to break encryption. Okay. Normally, you have privacy, you have security and content protection. If those are the things that you're protecting for, these things generally fight against each other. The more private you want to get, the more you lose on the content protection, the more you lose on the security in some instances. But there is actually a way, in Adam 1, that these 3 things can actually exist in balance.
Right.
And within the center of those, that you can actually have a productive Zero Trust connected network, right?
That's right. And that's what leads to higher productivity, both from a technology point of view as well as a human point of view.
Right.
That living in a Zero Trust world, just there's less traffic now on your network, right? There's less to pay attention to.
It's only the authenticated, what you actually want.
Right.
None of the noise that used to be there.
In fact, if you have a security operations center, they're likely going to be playing solitaire or twiddling their thumbs because there'll be nothing to pay attention to, right?
Right. Distributed custodial protection, David.
The reason this is such an important consequence is that we have always wanted this, but then we kind of sacrificed the need and want for distributed and said, well, the only way we can do it is if we centralize it all in our cloud.
Centralized control, distributed performance, right?
And so this is where we are now, is the control is still centralized,
right?
But everything in terms of the actual muscles, they are all distributed. So you get the best of all worlds. You get one pane of glass. You get a central place of administration, but the actual protection happens in a distributed manner.
Yeah. The value of living in a digital world where everything that's bad is outside, I think it's actually hard to describe that. And this is the part where we really need to break into song.
Don't worry, we won't.
No, thank you. We will definitely not do that, right? But just doing what everyone used to do, faster, harder, stronger, is not cutting it. No. SolariGate taught us that. Pegasus taught us that. All of the breaches, just read the news, that taught us lessons. And really stop being reactive and making a small adjustment here, and let's just take a full step back and say, design from first principles, And that's really what Zero Trust connectivity is. A solution based on first principles that is practical and it actually works.
That's right.
We'll do some more videos that breaks out into every one of these, but I think in a nutshell, this is a good introduction.
That's right.
Thank you.
Bye-bye.